So I'm the chair of the grafting technology working group. And let me introduce my working group members. Actually, 95% or so are the same members coming out from the first 5-year project. Richard Hassel, Shinzao, Carrie Rivard, and then Eleni Pugliaconi is a new member starting last year. She's a post-harvest physiologist and technologist, and she's adding a new type of project for optimizing transportation and looking at ethylene sensitivity of different species, rootstock, things like that. So the new addition is her group. Another addition this year, or this 5-year project, is Ricardo Hernandez, North Carolina State University. He's a controlled environment agriculture plant physiologist and technologist. And then he's mainly focusing on indoor artificial light-based heating chamber, and then also production chamber for the scion and rootstock. So it's a more advanced technology we are looking at. Matt Kleinhans, Ohio State, and myself, and Carol Myers. So those are the members. So the biggest objective of this working group is enhancing capacity and efficacy, or efficiency, sorry, capacity and efficiency of grafting nurseries. So during the first 5 years, we worked mainly for tomato grafting and watermelon grafting, and some of the outcomes of that 5-year project was tomato grafting pretty much known by many stakeholders and growers, users, and nurseries, both sides. Watermelon is getting into the market, and the nurseries started grafting watermelon in addition to tomato. Now in the new 5 years, our goal is to expand even more beyond traditional tomato and quote unquote traditional watermelon. So if you look at what kind of crop species we are working on, you see not just watermelon and tomato, but also pepper, eggplant, muskmelon, cucumber, all these different graftable crop species. Basically try to let users know those are graftable and those have benefit. And then also nurseries to get information about rootstocks, information about grafting technologies. All right, so we have under the the big objective number 3, enhancing capacity and efficiency. We have 3 sub-objectives. The first objective is more for refining and optimizing grafting methods. And then under that, we have, of course, protocol development still going on. And then also some of the things we haven't looked fully during the first 5 years, such as quantifying rootstock vigor, or evaluating a new idea of grafting, such as high grafting, and then high tech, the indoor production system. Our stakeholders, particularly nursery size, in a huge range, including those who graft by themselves and then share those grafted plants with neighboring farmers, all the way to the large grafting specialized nurseries who are grafting millions of grafted plants per year. So there are challenges, but by nature of our members working in extension side many years, many of the projects are, not all of the projects, but many of the projects are more geared toward small nurseries who want to graft different rootstock and scion combinations. All right. This is part of the outreach working group outcome, but I just wanted to add a few things because it's related to our objective also. We have been working on online grafting manual development. And then many of the working group members are involved, this working group members involved in this development. And then it's going to be online living manual. So we will be updating as we find new information. But it's consisting of 6 chapters, 14 articles, grafting methods, selecting rootstocks, and then also designing facilities, automation update, and those things. So it's a broad topics we cover. And then it's about to be available online, and we will be announcing this weekend or probably beginning of next week. So we will be sending out the information to the link. All right, so I'm gonna introduce quickly a couple of or the few projects under each sub-objectives. This is my group working on developing sort of better guidelines for different scion rootstock production scheduling. This is also more for new nurseries or someone who is first-time grafting or first-time planning grafting to get some kind of better idea of how many days to graft for this type of scion versus the other type of scion or rootstock. So we are trying to develop a simple model to predict time to graft using degree days, heat unit, and then also another environmental parameter which is likely affecting is daily light integral. So that's a photosynthetic active radiation integrated over time. So those two main variables seems to explain pretty much days to graft, and then also during grafting window, how fast you are moving away from the grafting window by tracking the stem width of the different scions and species. So that's one Ohio State project we are going on right now. University of Florida, Shinzao is working on grafting watermelon without roots attached. And then she recently reported to us in a working group meeting quite interesting result, which is basically fusarium recovery. So she grafted watermelon with different rootstocks, and then one half of the group is with roots attached. The other half is unattached, so that means excised roots. And then after heating and everything, she did a challenge inoculation of fusarium, and then see how much fusarium is actually transported to the scion through the grafted union. So I think idea is the root excision, removing roots, might increase the chance of fusarium getting into the system. And then some of the preliminary result on your right hand side is showing a slightly higher incidence of fusarium or percentage detected in grafted plants grafted without roots. So she's going to look a little bit more in this direction. And then also she's testing the performance, apart from the fusarium issue, the performance of grafted plants with and without root removal. And this is a Matt Kleinhans, a nice outcome. His group looked at 18 tomato rootstocks and 5 scions, and then developed this equation to evaluate vigor of the plants. Because catalog, the scion or variety and rootstock catalog doesn't really quantify the vigor, even though vigor is a quantitative variable. So he came up with this nice equation considering all the, the parameters listed right here, and then showing the relative difference between different scion and different rootstock. And then this is quite helpful to select the scion and rootstock, particularly if you are grafting very weak scion to a very strong rootstock. You may have some issue of regrowth coming out from the rootstock of particularly tomato. So I'm going to show you that how my group actually used this information, came out from Matt Kleinhand's lab last year. So we had a collaboration with the nursery and wanted to test different rootstocks, weak one and strong one, grafted onto a selected scion, and then wanted to look at the rootstock regrowth, which is problematic in a field crop production. Because growers don't want to grow rootstock, they want to grow nice, vigorous scion. So we wanted to test that different rootstock effect and selected the basically extreme rootstocks. One is weak, the other one is strong, and show that incidence of regrowth occurrence. And then weak rootstock didn't produce that much, and then strong rootstock produced regrowth. And then those 4 conditions are actually pinched. So the 2 header grafted plants, and then pinching also seems to exaggerate the regrowth. And we want to continue this kind of collaboration. The issue coming out was suggested by nursery or users, and then this grafting technology working group respond using our capacity to test different hypotheses, science-based hypothesis in more controlled environment or more in controlled field production setting, and then test, different ways, different solutions to address that issue. So we definitely want to continue this kind of effort as a group. This is Washington State, Carol Miles doing that. One of the things, she does a lot of projects, not only for this technology working group, but one of her projects was to develop easy, simple heating protocols workable for Washington climate, greenhouse climate conditions. And she was testing a combination of shading of the heating chamber in the greenhouse, and then also humidity level, specifically it's a venting level to maintain high humidity or a little bit vented, and then low humidity. And then looking at 3 different crops performance or the success of heating. And she was reporting that high humidity is very critical for solanaceous species. We tend to think solanaceous is easy to graft, but actually still, the higher, close to 100% makes the grafting success a lot higher. And then also some level of light needs to be introduced in a heating chamber compared to complete darkness. So those are the things some nurseries already know, and then some scientists probably know by experience, but not really specifically spelled out. And then she did in the base of her climate conditions. All right, and then this one is the Kansas State University Chieri River result. He has also several projects, and then this is the most relevant one to our working group. He has been testing removal of leaves to enhance the grafting success by reducing the surface area of transpiration rate. And then he demonstrated nicely, successfully, that reducing leaf area is actually enhance the grafting success. And then also interesting thing was adventitious root development coming out from the grafting union was largely suppressed by removing or more removing leaf area before going into the heating. So those are also things toward, you know, someone or the small nurseries or small growers who want to graft by themselves without having much resource like controlled environment, fogging, or things like that. So it's very helpful for local growers and then also nurseries. All right, and then Elaine, Priya, Connie, and my group working together for optimizing long-distance transportation. So we came up with this idea several years ago, and then this became a formal project in this phase of grafting project. And we have been talking to nurseries, large nurseries, and small nurseries. Some say transportation is a real issue. Some say transportation is something they already figured out, so they are happy with that. But we still want to find out any potential issues that prevent market from growing even bigger. So we wanted to start with nursery survey and then also user survey, what kind of problem they have seen, disease outbreak coming out from the grafted plants, or quality deterioration of the grafted plants shipped for long distance, edema, intumescence during the high humid transportation, typically the issue in tomato. So those things we want to find out by doing survey. And Dr. Priaconi's team is, I think, ready to deploy or distribute the survey, and we will design the experiment. And then her effort and expertise is around the ethylene, you know, post-harvest, pre-harvest technology. And then my expertise is controlled environment to basically extend the transportation distance to cover up the much bigger, much wider market for the grafted plants. So that's just the beginning of the project. Okay, a few more slides. So the third sub-objective under our working group objective is a new project, which is indoor, low cost, not the super high-end, indoor production facility, both for heating and then also production of scion and rootstock. So for under this sub-objective, we have two groups working on. One is Ricardo Hernandez from North Carolina State University and his students. And then also a Richard Hassel group doing that. Idea is shipping container based. So it's a scalable 30 feet or 40 feet. I forgot the exact length, but the shipping container, which is insulated one. So it's nice for temperature control. And then build a placing shelving unit like this one inside, and then make the internal environment optimum for growing scion and rootstock, as well as heating the grafted plants. Idea is creating something low cost, but totally independent from outdoor climate, so that grafting quality, graft union quality, and grafted plants quality are consistent, independent from the weather changes. So that's the idea. And then just started, this is Ricardo's preliminary study looking at different controlled environment approach to change the quality of the plants. This specific project he shared in the working group meeting was looking at a way to stretch the rootstock or scion stem, because stem length is a quite unique quality parameter for grafted plants. And yet in a artificial lighting environment, electric lighting environment, tends to have a very, very short inner node length, or the hypocoral length. How can we extend that? And then his approach was adding farad. Farad is a traditional light quality that extend the stem, and then it works really well in electric lighting conditions, because the main light doesn't contain usually farad. So his graduate student, and then Ricardo Hernandez, demonstrated successfully using a scion, brandy wine, and then also rootstock, and then this is with farad, extending the stem successfully. So more research is coming out from his group. It's very unique new technology. All right, so overall progress, we propose 4-year project, and we are toward the second half of well, actually we are in the second half of second year. But my observation, we are still finishing up the first year project. It's actually natural, because getting the team in place, and then training the new members of the team, it takes time. So I don't feel it's too much a problem. And I'm sure, I know everyone in this working group is a very hard workers. So we will generate more interesting outcomes, and we are looking forward to having more opportunities to share interesting finding, preliminary results, and things like that with our stakeholder members and beyond. So this is my last slide. We, however, we had a meeting a couple of months ago, working group meeting, and then we recognized that we need to, have more communication with our stakeholders and other working group members. Many of the working group members have how do I say, multiple membership with other working groups, so they know what's going on. But I think we need a sort of crosstalk within the group, and then also beyond the group, horizontally and then also vertically, to enhance the understanding of what's going on, what's the potential issues in technology side. And then I like to use this capacity of being able to test many things in the academic setting. And then we have a different climate zones covering. So I like to do that more close communication and collaboration within this group and beyond that group. And then also we are wondering if we should start doing more research-oriented webinar or some kind of, seminars, web-based seminars, to share the information periodically without waiting, like conferences, international conferences coming up, or national horticultural annual meeting. But within this group or beyond this group, we are wondering if that is any benefit, and then if our stakeholders, and then particularly advisory group, would support that kind of activities out of this working group. So with that, I'm gonna stop, and if you or any of you have any questions, I'm happy to answer.